Continuing with the insurance example, we're now going to calculate the variance and standard deviation of a discrete random variable distribution. Alright, up here in the box we have the formula for variance. By the way, I just noticed, and I had to fix it, that and I lifted this from your textbook, and it just has sigma. It should have sigma squared for variance. Okay, anyway, here's variance, and the formula says you take a value of x, you have to subtract it from the expected or the mean value of the distribution, square that difference, and multiply by the probability of x, and you have to do that for every single one of your x values and sum that all together. Once you have your variance, you are then going to take the square root of it, and that will get you your standard deviation. So let's look at our example. We have our three values of x. So here's our payout. These are the only possible values of x. We have their associated probabilities. The formula up here says take the value of x minus the mean. So here we have it, 10,000 minus 20. We found a few slides back that the expected value for the payout, or the mean value for the payout, was equal to $20. So we take each value of x, subtract from the expected value, and here's the differences. Down below here I have the differences. They get squared, and then each one of these differences is multiplied by the probability of the x value that that difference was calculated from. So the 9980 was calculated from an x value of 10,000. Its associated probability is 1 in 1,000, so that's what's going on right here. The 4980 came from the x value of $5,000 payout. Associated probability is 2 in 1,000. And then finally we have the probability of paying out neither for death nor disability. So we work all that out, we sum it all together, we get 149,600 squared dollars, which of course is a ridiculous unit. So typically we will take square root of variance, and then that gets us back to a unit that is applicable to the data that we have. So in our case, the standard deviation is $386.78. So we can conclude that the insurance company expects to pay out on average $20 per policyholder with a standard deviation of roughly $387. Now, knowing the mean and knowing the standard deviation, we could construct for ourselves an interval within which we expect to find the true payout, if you like. And supposing this distribution followed a normal distribution, we could work this out and go the mean plus or minus 2 standard deviations of the mean. Now, if this followed a normal distribution, then 95% of all payouts that the company might expect to pay out should fall within the 2 standard deviations of the mean. And if I work that out, 20 minus the 2 standard deviations to 20 plus the 2 standard deviations, I'm going to get a negative $753 roughly, up to a positive $793. And of course I can't have a negative payout, so I could say that we would expect 95% of all the payouts to fall somewhere between $0 to $794 per policy holder.